Hello students, let us discuss how to find the inverse with determinant method. Basically there are few steps involved in that. That is, firstly finding the determinant of that particular matrix, then finding the minors, then finding the cofactors, then finding the adjoint, and then finding the inverse. Basically they are interlinked. We can find cofactors only if we have found the minors. We can find the adjoint only from the cofactors, and finally we can find the inverse if we have adjoint earlier. That means it's a flow chart. Whenever we are going to find the determinant or inverse of matrix, firstly we'll find the determinant, then we'll find the minors, then we'll find the cofactors, then we'll find the adjoint, and finally we'll find the inverse of that particular matrix. Let us discuss the steps one by one. So firstly we'll discuss determinant. So what is determinant? Basically it is a way to assign a value to a matrix which is a square matrix. It's having a particular criteria. We do have a particular criteria with which we assign a value to a matrix that is square one. For other matrix we are not assigning any value and we can't find the determinant. We can find the determinant only for square matrix. Now let us further discuss about the determinant. Let us we have a matrix of order 3 into 3, which is square matrix with the elements 2, 3, 1, 7, 5, 4, minus 1, 2 and 3. So first step is you should know that every element has their own position sign. Yes, every element has their own position sign. That is, sign is position bound. Every position has a particular sign for that, and that can be determined with this minus 1 the power I plus j, where I represents the row and j represents the column. Let us find the position sign for 7. As it is in the second row and first column, so I is 2, j is 1. So that means minus 1 the power 2 plus 1, that is minus 1 the power 3, that is minus 1. Here 1 doesn't matters for the time, the sign matters, it is a negative. So 7 has a negative position sign. Likewise we can find the sign of 3. It is in first row, second column, 1 plus 2 again 3, minus 1 the power 3 is again minus 1, that is negative. If we're finding the sign for 3, it is in third row, third column, that is 3 plus 3 is 6, minus 1 the power 6, that is plus 1, it will be positive. It means when the sum of I and j is even, it will be having positive sign. When the sum of I and j is odd, it will be having the negative sign. So I've written all the position signs, that is plus, minus, plus, minus, plus, minus, plus, minus and plus. And how we're gonna use that to find the determinant, we'll see. Then you should know, while finding the determinant, we have 6 methods. We have methods depending upon number of rows and columns. As there are 3 rows and 3 columns, so we have 6 methods. We can find through first row, find through second row, find through third row, first column, second column, or third column. We can find with either of the row and either of the column, and the answer will be same. If one is finding with first row, second is finding with third row, and third is finding with third column, the answer will be same for all 3 solutions. And finding the determinant is also known as expanding the matrix, because we're gonna expand this thing. Let us start by first row. As first row has 3 elements, 2, 3, 1, so we have written the 2, 3 and 1 over there. I've left the spaces just because we won't gonna fill them with particular criteria. Now when we talk about 2, it is in first row, it is in first column. Leave the first row and first column both. First column and first row both. Remaining elements are 5, 4, 2 and 3. So I've written over there 5, 4, 2 and 3, and find out the determinant of that. Similarly, when we are talking about 3, it is in first row, leave that. It is in second column, leave that. We are left with 7, 4, minus 1 and 3. I've written over there. Likewise, if we talk about the third element 1, Leave the first row and third column, we are left with 7, 5, minus 1 and 2. 7, 5, minus 1 and 2. So that means we are multiplying number of row with determinant of 4 elements that we're gonna find after leaving the row and column in which that particular element belongs. Now, to find 2 into 2 order determinant, it's quite simple. Just cross multiply them. 5 with 3 and 2 with 4. And just subtract 2 into 4 from 5 into 3. That is 5 into 3 is 15. 4 into 2 is 8. Just subtract that. That means minus 8. And likewise, 7 into 3, 21. 4 into minus 1, minus 4. Subtract that. 7 into 14, minus 5. And we are multiplying them with the individual elements. Secondly, in front of elements, we are placing their position signs. At position sign of 2 is positive, so I placed positive over there, as position sign of 3 is negative, and position sign of 1 is positive. Now we're going to solve them. 15 minus 8 is 7, 7 to the 14 over there. Minus will become plus. 21 plus 4, 25. 25 into 3 is 75 with a negative sign. Minus again plus. 14 plus 5, 19. 19 into 1 is 19. We solve this and we got 42. Oh sorry, it is minus 42, which is the determinant of this matrix. Let us find the determinant with some other row or column. Let us expand this row on third column. So again, third column has 3 elements, 1, 4 and 3. Again do the same criteria. For 1, leave first row and third column. We are left with 7, 5, minus 1 and 2. We find it their determinant and multiply it with 1. Likewise, for 4, leave second row and third column. We are left with 2, 3, minus 1 and 2. We find its determinant and multiply with the 4. Again, we talking about 3, left third row and third column. We are left with 2, 3, 7, 5. Find their determinant and multiply with the 3. Again, we have placed a position signs over there. 1 having the position sign positive, 4 having the negative, 3 having the positive. Again, we solve the same thing by multiplying, by adding, by subtracting, and we got the answer to be same. You can try the rest of the 4 methods. So you can try with the second row, you can try with the second column, you can try with the third row, you can try with the first column, and you're going to see that answer going to be same for each and all methods. So next we'll talk about minus. Before that, take a break, just try on your own, find determinant of few matrices so to be good in that part. Then we'll talk about the minus in next video. Thank you. Stay tuned.